So this is the solution to the first Newton's second law problem. I am going to go right to a free body diagram so we can see what belongs on the picture. Here's the ground, and here's the crate. So I'm obviously going to isolate the crate. 25 kilograms. And you were given a 57 Newton force acting at 22 degrees. So, since we've isolated the crate, we approach these in a very similar fashion as the equilibrium problems. We need to decide on some axes, and we need to draw all the forces acting on the object. Since you were told the crate is moving to the right, the best choice for axes are x to the right, and we will choose y up in this case. It makes the most sense. We probably won't even need to deal with the y-axis since there is nothing interesting happening in the y direction. So what other forces do we have? We have the weight of the object. mg. 25 kilograms times 9.8 meters per second squared is 245 newtons. Remember, we do not use negative g when we calculate the weight of an object. We have a friction force which was given. Just so we know how to draw friction, we will learn more about the nature of friction later on. Friction force always opposes which way an object moves. Not which way other forces act, but which way an object moves. It is always 180 degrees opposite motion. Since the crate is moving to the right, the friction force must be to the left and parallel to the sliding surface. It was given as 10 newtons. Make sure we always draw our arrows. And there is one other force. Since the crate is sitting on the ground must push up on the crate. Just like in the problem where we had the sled on the incline, we have the normal force, N, pushing up. Those are all the forces acting on the object. We have to resolve things into components. The only one we need to deal with is the 57 Newton force. 57 newtons cos 22. Acting up, we have 57 newtons sine 22. All we care about is the x direction. Since the crate is moving to the right, that's the only place there is going to be an acceleration. So here are our x-directed forces. We have nothing else in the x direction, and here's our equation. Sum of the forces in the x direction is mass times acceleration in the x. And now we can fill in. 57 newtons cos 22 minus 10 equals m, 25 kilograms, that's mass, times a. There's our equation, and when we solve this, we get a equal to 1.71 meters per second squared. That is the answer to the problem. Note, for this problem, we didn't have to do any work in the y direction since the acceleration was all in the x.